Welcome to Korean Grade 7 Math. In today's lesson, we'll learn about prime factorization. We'll go step by step and see how a number can be broken down into prime numbers. In the previous lesson, we learned about exponents. Today, we will use that idea when we write prime factorizations in a shorter form. And in the next lesson, we'll use prime factorization to find all divisors of a number. Prime factorization means writing a number as a product of prime numbers. For example, 12 can be written as 2 times 2 times 3. Since 2 and 3 are both prime numbers, this is the prime factorization of 12. But not every factorization is a prime factorization. For example, 12 equals 3 times 4. This is true, but it is not prime factorization because 4 is not a prime number. In prime factorization, every factor must be prime. Here is the basic idea. Start with a composite number. Split it into factors. Then, keep factoring until every factor is prime. When all the factors are prime, you stop. Let's start with 12. First, we can write 12 as 2 times 6. But 6 is still composite, so we factor 6 again. Since 6 equals 2 times 3, we get 12 equals 2 times 2 times 3. Now all the factors are prime, so we stop here. We could also start a different way. For example, 12 equals 3 times 4. Then 4 equals 2 times 2. So again, we get 12 equals 2 times 2 times 3. Even if the process looks different at first, the final prime factorization is the same. A useful way to organize prime factorization is a factor tree. Let's use 72 as an example. First, split 72 into 8 and 9. Then, factor 8 into 2 and 4, and 4 into 2 and 2. Also factor 9 into 3 and 3. Now, every branch ends in a prime number. From the factor tree, we get 72 equals 2 times 2 times 2 times 3 times 3. Using exponents, we can write this more simply as 2 to the third power times 3 squared. This is why the previous lesson on exponents is important. When writing a prime factorization, remember these points. First, write the number as a product. Second, all factors must be prime numbers. Third, arrange the result neatly. And if a prime factor repeats, you can use exponents. Here are some common mistakes. Writing 20 as 4 times 5 is not enough because 4 is not prime. Writing 24 as 2 times 12 is also not complete because 12 is still composite. You must continue until all factors are prime. Now, try these on your own. Find the prime factorization of 15, 20, and 36. Pause the video if you want a little more time. Here are the answers. 15 equals 3 times 5. 20 equals 2 squared times 5. And 36 equals 2 squared times 3 squared. Today, we learned what prime factorization is and how to find it step by step. In the next lesson, we'll explore how to find all divisors using prime factorization. If you enjoy learning math like this, consider subscribing to Future Math Lab. See you in the next lesson.